So here we are with the 4-4 assignment. Woohoo! So we're going to find the amplitude of the function and use the language of transformations to describe how the graph of the function is related to the original sine. So, taking a look at this, we've got a 2, so our amplitude is 2. And then describing what happens, that means it's going to be a vertical stretch. We could also say it doubles in height, because it used to be 1 and now it's 2. Alright. So the next one here, the altitude is 4. Okay, so it does say -4, but of course that's not part of the altitude. It's an absolute value of that a value. And so this one's also going to be a vertical stretch. It's going to be 4 times as tall. And then this negative means that it's going to reflect. Whoops, started with an F. Reflect on the x-axis. So as a sine graph, that means that it's going to start by going down versus up from the origin. Alright, and then the last one is 0.73, so the amplitude or the height is 0.73, which means that it's going to be a vertical compression. And it's going to be about 3/4 of the height, but I'm not really going to say that because we don't really necessarily need to know the factor of it. We just need to know that it was either vertically compressed or stretched. Alright. Alright, so now we're going to find the period of the function. So we do need that formula, and of course it will be referenced on your formula sheet, so you can have that right here. Oh, it's not on here. Well, that's exciting. Or maybe it's up above here. I thought it was part of our formula sheet. Either way, the period is b over 2 pi, absolute value. So the period is absolute value of b over 2 pi. And never mind, that's the period, it's the opposite. Alright, because generally 2 pi would be the normal period of your cosine and your sine, and so we're splitting it up by the number of times it has a b. So, we're finding the period and then using our language to talk about how it's related to cosine of x. So the first one that we have here is that it's going to be a period of 2 pi over 3. So one of its undulations will happen within 2 pi over 3, which is 2/3 of the way around. And so that means that it's going to horizontally compress. Because if it used to be a 2 pi stretch, and now it's a 2 pi over 3, or 2/3 of that, it's going to be less. So, compressed. The next one has a -7. So our period is going to be 2 pi over 7. And so again, that's a horizontal compression. But then we also have that negative, and so that means it's going to flip across the y-axis. So instead of having it start up here at 0, 1, it's going to end up flipping, so it'll be at 0, -1 to start with. Alright, and then the last one kind of has two things going on. So our period ends up being pi, because it's 2 pi over 2 for this 2 inside here. And so again, it's going to be a horizontal compression. And then that 3 means that it's also going to be a vertical stretch. So very skinny and very tall is what's going to happen there. Alright, moving on, we're going to find the amplitude, period, and frequency of the function and use it, not your calculator, to sketch a graph of the function. It does say between -3 pi and 3 pi, and we just have 2 pi, so we're just going to go with the graph I gave you versus extending it out. That is not necessary. So, for number 13, our period is going to be 2 pi over 1/2, because a half is our b value. So that's really going to be 4 pi, which is probably what, anyway, so 4 pi is our period. And then the frequency is going to be a half over 2 pi, right? The b over 2 pi. So let me think about that. That means 1 over 4 pi. Is when each of the pieces is repeated, or how many times it will happen within a revolution of 2 pi. And then the 3 means that our altitude is 3, so that's going to mean that we will be sandwiched between these values. Alright, and so it's going to be not shifted, so that's good. So it's going to start at 0, 0 like it would have. Its entire period is 4 pi, which means that by the time it got to 2 pi, it's only going to be halfway through. So if we go up from 0, 0, we're only going to be halfway through by 2 pi. And so that means that over here, by the time we get done, we'll have had 1 revolution, because this entire length here is 4 pi, and so we'll have 1 revolution within that. And we stretched it, and okay, so that's it. Alright, the next one is number 15. It's going to have a period of, let's see, 2 pi over 2, so it's going to have a period of pi. It's going to have a frequency of 1 over pi, just the flip of your period. And then it's going to have an amplitude of 3 halves. And then it'll also flip on the, let's see, y-axis. Is that what it is? No, x-axis. Alright. So let's see, with each of these pieces, our amplitude is 3 halves, so that's 1.5. So that means that we're going to be sandwiched here, or bounded. And then the period is pi, so by the time it gets here, it's going to need to have done an entire revolution. And if it flips on the x-axis, instead of going up at 0, 0, it's going to go down at 0, 0. Then breaking it up into the pieces, if it starts here and goes down, it's going to go down to here, middle, up, and back down. So making that kind of snake shape within here. Same thing, each one of these revolutions of that circle is going to come down. There we go. Alright, so definitely flipped on the x-axis because it would have, these are sine, yeah, gone up. Pi, it does 1 revolution within a pi. So all the way down and back up and ready to go down again. And yeah, so there you go. Alright, next piece, they want you to graph a period of the function and use your understanding of transformations, not your graphing calculator, to do this. So, this one here is sine, but the only difference is that it now goes to 2. So it's going to be sandwiched at 2 and negative 2. And since it doesn't have a b value, its period is 2 pi. And so all it is just a stretched function. So it's going to go up at sine, middle is pi, down at 3 pi over 2, and back to the beginning at 2 pi. And so that is one revolution of it. That's all they wanted. Alright, then the next one is 3 cosine. And so 3 cosine just means that our amplitude is 3, and so we're going to be sandwiched between here. We need to know that cosine would have started at 0, 1, but of course now it's going to start up at 0, 3, just because of that 3. Otherwise, it's a regular cosine with no change in period. So it's going to go down through at pi over 2, back down at pi, up, and then back up again, having done one revolution. There we go. And then the last one is a half sine of x. So that means that it's going to have a height of a half, which is kind of small. It's also sine, but it's doing negative sine, so it's going to go down from the beginning. It doesn't have a b value, so its period is still 2 pi. And so we're going to go down. Oh, its period is 2 pi. I was going over too far. So down here, back to the middle, back up, and back down again. So as you can see, that 0.5 really does squish it. And then, of course, the negative makes it go down. So this is all one revolution based on what is given. Alright, then the next one wants you to graph 3 periods of the function, and so if it doesn't fit on one graph, we'll just use the one graph. But we're going to use our understanding of transformations and be sure to show the scale. Okay. So this first one here, number 23, has a period of 2 pi over 2, so pi. It has an amplitude of 5, so it's going to actually be not big enough for this graph here. And then that's it, and then it's sine, so it's going to go up from here. Alright, and so its period is within a pi, so that means that it's going to have to do the entire oscillation before it gets here. And it's all the way going up to 5, so it's going to go up to 5, back down to the middle, down to -5, and then back up to the middle. And they want 3 periods, which we'll be able to fit. So here's one period going all the way down and up again. And then we'll do another one all the way up, down. And then because we can't fit one the other way, we'll just go back down to, we'll just go to the left. And so down, up, all the way up to 5 and back down. So that's 3 periods of the function, having one here, separate here, and here. So 3 periods. Alright, then we move on to the next one. It's a cosine. It's got 3x. So that means its period is going to be 2 pi over 3. So 2/3 of just 1 pi, meaning, well, they're not broken into thirds. So let's see if I can do that. That looks like a third. So this would be pi over 3, and this would be 2 pi over 3. And then 3 pi over 3 would be pi. Then our altitude is a half. Oh, that's going to be gross. And that's all they give us. So it's going to be at a half. And then its period is going to happen within a pi. Oh, sorry, a 2 pi over 3, so within this piece. Which means that I'm going to need to, from this point, break it into 4 pieces, otherwise I can't fit the whole idea in it. And it's cosine, so it's going to start up at the top. In the middle of what it's doing, it's going to be at the bottom, and then it's going to be back at the top. So we can kind of just sketch it that way. Then another 2/3 pi, so 2/3 plus 2/3 is 4/3. So, it's going to be here. And then another third between here. Since the thirds aren't shown. There we go. And so then it's going to go back down at pi, come back up again, and then back down and back up again. It's kind of ugly, but there it is. So that's 3 revolutions because it's got this maximum here. Alright, and then the last one is 4 sine, so that means that its altitude is going to be 4. So we'll have this bound as well as this bound. And then it's got x over 4, which means that the period is going to be 2 pi over a fourth, which really means that it's going to be 8 pi as your period. So the only amount that we have is 4 pi, and so we're just going to have half of a revolution. And so, of course, if we were doing what they said, which is provide 3 of them, we'd have to have a very long graph here. So, let's see. It is sine. And so sine is going to go up, but within 2 pi, because if we divided this by the 4 pieces that we would have, 2 pi is only going to be one of the arches of this. So going up, but then it would have come back down, and then going down, and it would be coming back up. So it's only going to be half of what we've seen, so that's going to be very stretched. Alright, whoops. Alright, then the next one, we're going to write the function as a phase shift of sine. So, what we're seeing is that sine would generally be going up, and then, what is this, pi over 2, and then at pi it would be coming back down. 3 pi over 4, it would be down at the bottom, and then at 2 pi it would be back up again. But we want negative sine to be this, and so negative sine is just going down first, then up through x, up, and then down again. And so how do I make this red one shift to become the green one? So as you can see, write the function as sine. So as you can see, it ended up shifting from red to green by adding pi. So if we add a pi to sine, we're going to get negative sine. Because between one peak to the next, there's pi difference. And it's going to the right. Oh, so actually it should be minus pi. Because any movement to the right or left is opposite of what you would think. So that means that we're going to do sine of x minus pi. So yeah, so sine of x minus pi equals negative sine of x. Alright. The next one, they want you to write negative cosine as a phase shift of sine. So again, I will draw sine. Going up, down. Oh, forgot one. Down and up again. And then we want negative cosine. So let's see, negative cosine. Normally cosine would start up here. It's going to start here because it's negative cosine. It's going to travel down, through, down, and through. And so we can see that our peak here has gone pi over 2. And to get from sine to this negative sine, it's gone right pi over 2, so that means that we want to go negative pi over 2 to be able to shift it back. And so our new equation is sine, but we're going to take pi over 2 and subtract it from it, because that would have equaled negative cosine. Whoops, 2 c's in cosine. Cosine of x. So you're just trying to find that peak or one of those identifying features and see how it shifts to become this so that we can make the new equation. Alright, and then we need to state the amplitude and period of the sinusoidal function relative to the basic function, so just sine or cosine, and the phase shift and the vertical translation. Yikes, that's a lot of listing. Okay. So in number 61, the amplitude is going to be 2. because it's this 2 here, but the absolute value of it. Then they want the period, and so the period is going to be our b value, which we don't have one of, so it's just going to be 2 pi. Because it would be over 1, but that's not changing it. And it's phase shift and vertical translation. So it's phase shift means that it's going to shift right because of the negative there, pi over 4. So instead of being at 0, 0, it'll be at pi over 4, 0. And then it's also going to go up 1. So as much as the amplitude is 2, it's actually going to center around 1 and then go up to 3 and down to negative 1. And we don't graph it. So amplitude here is 5, continuing on, amplitude is 2, and amplitude here is 7/3. Then we can continue with our period. So period is going to be 2 pi over 3 in this one, because of that value there. This next one, I don't know why they don't have parentheses around it, but I assume that is within there. It's because it's all multiplying, so they didn't need to put parentheses there. Okay, fine. And then, 2 pi. So it's 2 pi over 2 pi, so our period is 1. That's weird because it canceled the pi, but it's all good. And then the period for the last one has a 1 for the b value, so it's just 2 pi again. Then based on what we have here, we're moving right pi over 6 in order to start our cosine function. This one here is not right or left, so we don't have one of those. And then 5 halves is how we're shifting this next one, so left 5 halves. And then the last one, talking about if it's up or down, so up a half for that one, up 1 for 65, and down 1 for 67. So kind of once you get that pattern of how to do it, you can fill that in pretty easily. And so that is the end of our assignment. Graphing the sinusoidal is actually, from what we've had in the past, the most complicated part, the most kind of hard to visualize. So once you graph it by hand, go ahead and grab your calculator and graph it as well in radian mode and see if it matches what you have, because otherwise sometimes you get too big or too small or whatever, so you just want to be able to compare.